first coefficient not equal to 1. Whenever this isn't the case, the way that I set these problems up are always going to be the same. I know that some of you guys have learned how to do this differently. Depending on who you had for algebra, you might have done a box method, the X method, whatever, multiple different things. Yeah, I'm not going to say one way is better than another. The reason that I use this method is because it's very systematic. It's the same procedure each and every time. I think it's pretty easy to follow through here. So what I do is I multiply the 3 and the 10, first and the last, and I get 30. Good. So what times what is 30? You add together, get positive 17. Well, 3 and 10 would work, but that doesn't give me 17. 15 and 2 does. Okay? So do I have to worry about any of my signs with this problem? Nope, don't have to worry about any signs whatsoever. So now it's just a matter of what I call factor by grouping, or split middle term. 3x squared plus 15x plus 2x plus 10. Does it matter which one I put first, the 15 or the 2? No. Makes no difference at all. One suggestion I will make is that if your signs are alternating, one's positive, one's negative, put the negative one first. It's a little bit less messy. So from here, it's just a matter of grouping. Now, what I'm doing here by grouping, I'm going to find the GCF of each of those two terms. Remember, GCF is greatest common factor. Greatest common. Yes. Yeah, very good. So when I look at what goes into both 3x squared and 15x, it's going to be 3x. So I factor out a 3x and x plus 5. Now, what does 2x and 10 have in common? 2. Not just 2. So I factor out a 2, and I'm left with x plus 5. Are the things in parentheses the same?
Yes.
Okay, if they're not, what happened?
You screwed up.
You screwed up. Start over. Watch a sign. Look for something silly. Now, if they're the same, write it down. And then what's left?
3x plus 2.
And you're done. This method does take a little bit longer way of going about it sometimes, but it's very, very, very systematic. Okay? It forces you into it. Forces you to the groupings. Okay? Same thing with 40. Now when I multiply the first and the last, I get what? 6. All right. So what times what is positive 60, but when I add together, I get negative 19?
I don't know.
Well, first thing, are they both negative, both positive, or are they a mixture?
Positive and negative.
They're both negative. They're both negative. They both have to be negative because you have two numbers that are multiplied together to give you positive, but you add together to give you negative. They both have to be negative.
I thought you meant the 60.
Yeah.
I was like, I know you should have said.
Oh, I'm sorry. I meant the term. I meant the.
We got you.
Okay. So what was it? 15 and 4.
Oh. All right. Oh.
See there. And those are both negatives. Okay. So when you split your middle term out, you get 10x squared minus 15x minus 4x plus 6. Now, when my third term is negative, I always do that same change opposite there to force myself to remember to factor out a negative while I'm grouping. And I'll explain to that why here again in a second. Again, GCF of the first group is what?
5.
5x. So I'm left with 2x minus 3. Now, by changing this into that, let's see, it's minus 4x squared, or 4x plus 6. By changing this into a plus, a negative here, when I group them, it's reminded me to take the negative out. A lot of times you guys will forget that, and you're going to miss a sign. Okay? So when I take that negative out, what's the GCF of 4 and 6? Yep, we're taking out a -2. So -4 divided by -2 is positive. Positive 6 divided by -2 is -3. That's what allows me to get the same term within my parentheses. Okay? Now, the terms are the same in there. I write it down. Does it matter which order you put them in? No. What property in math tells you that multiplication order doesn't matter?
Flexible.
Wrong. Commutative, very good. All right, it's commutative property because you're commuting, you're moving.
What's the flexible mean? Add.
You are yourself. 1 equals 1, 2 equals 2.
3 equals
3 doesn't equal 4.
4.
Not yet.
1 plus 1 equals
2 plus 2 is 5.
Okay, Orwin.
Where is this going?
Orwellian.
This is going to.
I don't know. Let's go into these.
3.
Oh, yeah.
Back to these two, please.
Somebody just.
Now, I threw a curveball at you here.
Which one's the curve?
1.
What should always be your first rule of factoring?
5.
Check the coefficient.
Is there a GCF? Whenever you have factoring problems, and this really hasn't come up yet, anytime you go for a factoring problem, the first thing you always want to just briefly look, see if there's a GCF. Because if there is, you have to factor it out. I'll explain to you, I'll show you guys what happens here in a second. So try these two. I'll pause where we're at and see how you do. In this one here, everything's divisible by 2. Factor the GCF out first. You right now have 2x plus 4. Factor out the 2's. You're left with x plus 2. What's 2 times 3?
6.
What are two things you multiply together to get 6? You add together to get 7. 6 and 1. So this becomes 2, 2x squared, 6x, 1x.
Wait, why didn't you multiply? Yeah, why didn't you just do split?
I am.
You aren't 4 times 6.
Okay. What's the first rule of factoring?
Take those out.
GCF. I took the GCF out. Don't erase what you have yet. Just wait 1 second. When you group it, you have 2x, so it's x plus 3. So you're left with 2 times x plus 3 and 2x plus 1. If you didn't factor out the 2, you probably have a term in there that might be 2x plus 6 or 2x plus 4 or, excuse me, or 4x plus 2. Okay?
We have to do that?
You have to factor out everything. You cannot leave something in parentheses where it says 2x plus 4 in parentheses like that, because you can still factor it.
Okay.
See what I'm saying?
So, say we don't factor the 2 out at first and we get 2x plus 4, we can just.
Then you can take out the 2 later.
Okay.
That's fine. The reason that I do the GCF first is sometimes it's easier. The numbers become a little bit smaller, and a lot of those you can probably do in your head. That's really the main reason for GCF, if possible. Okay.
So if I have it x plus 3 times 1 before x plus 2, I can just take out.
Yeah. So your last step then would be to take out the 2 and leave it all there. Now, there is a time that you don't need to worry about that, and a time that you do have to worry about it. The time you have to worry about it is here, when it just says factor. The time you don't need to worry about it is when it says, when it's set equal to 0. Because if it was set equal to 0, you'd have to divide it out anyway. You have that 2x plus 4 equals 0. When you subtract 4 divided by 2, you're going to get the same result. So if it's an equals 0 problem where you have to solve for a 0, you don't have to really worry about the GCF part. But if it was, then if it was just regular factor. Okay? Same idea here with 6, 33, and 15. I could factor everything out by a 3. Yes, sir? If I factor out a 3, I get 2x squared, 11x, and a 5. Yes, sir?
What's GCF?
Greatest common factor. What's the biggest thing that goes into all 3 of them? What's 2 times 5?
10.
What times what is positive 10 that I add together to get negative 11?
Negative 10 is 6 and 5. Gosh, no.
Negative 10, negative 1. Once again, I just have to be careful for my second negative. Factor by grouping. Okay. Now, if you didn't factor out the GCF on that one of your terms would have had a multiple of 3 in it. Okay.
Did you, John?
Go ahead.
If you did it through the various times after first and you did it like reduce it, is that?
Because it's still, you can still factor further. That's why I'm telling you to look for it first. You can, because that way you don't forget it. Or recognize you had a, 6 and 3?
Yeah.
Did you have 6x minus 3? You can take out a 3. Okay. Yes, sir.
You're gonna do that way when all of them can be factored by the same number?
Yeah.
Oh,
Mm-hmm. Yep. Let's do some others. Yeah. If this equals 0, this is good. The only thing that's left now is to find your zeros. You have no problem with doing anything with this 3. It doesn't do anything. Your zeros here are 5. Add 1 divided by 2. 1 half. Nothing changes except for just finding out where it's crossing the x. Are we good? Another tricky style. When you have a negative a value. In this case here, I have negative 3x squared minus 15x minus 12. Whenever I have the first term negative, I'm going to factor out the negative. Okay? I'm going to factor out a negative. But in this case, I can factor out a negative 3. Okay? So what I'm doing here is the GCF for all of these guys wind up being negative 3. So if I take out a negative 3, I'm left with x squared plus 5x plus 4. Because I'm taking out the negative. Negative 15 divided by negative 3. Negative 12 divided by negative 4. That's where I'm getting the positives. Okay? So now what times what's 4? You add together to get 5. 4 and 1. And you're done.
Wait, should it be one?
All I'm doing here is taking that negative out. Always get rid of the negative, but you have to just undistribute that negative of all 3 terms. Okay? That's where you guys will forget. Try the next one. What's wrong?
That's just, it's just.
Yeah, there's nothing else. It doesn't say equals 0, so all I can do is just factor it. I didn't do anything else to it. So do this one. Factor that one. whenever you have a negative problem, whenever you have a negative a value, the very first thing you want to do is factor out the negative. Do that right away. Bless you. In this case here, I can divide everything here by -2. GCF is 2, I'm just factoring out the -2, that's all. So I have a -2 coming out. That leaves me 2x squared minus 5x minus 12. -4 divided by -2 is positive. Positive 10 divided by -2 is negative. Positive 24 divided by -2 is -12. I'm bringing the negative out. Now I factor this like I would earlier. This -2, just bring it all the way down to the bottom to where your answer is going to be. That's all it's doing. It's already out. 2 times -12 is -24. What times what's -24? You add together to get -5. -8 and 3. So I have 2x squared minus 8x plus 3x minus 12. From here, I go back to my grouping. GCF is 2x. I'm left with x minus 4. GCF, 3x and 12, 3. I'm left with x minus 4. Those are the same, so I just write it down next to the -2 I already took out. Now my answer's good. Take the negative out.
That's the same answer.
No, the negative should be out because it needs to be negatives inside. You can still factor out the negative.
GCFs that you take out don't get
Ask.
So
Sure.
you have to make them.
Sure.
Yeah.
Excuse me.
Just route my calculator.
All right, here's another one. Another negative. What are you going to do first?
Take out the negative.
Take out the negative. Bring out your dead.
Gary? But that doesn't work.
I understand now.
Darn it.
What? Huh? Hold on, I'm about to be done.
Oh.
Yeah, I got the same. I just didn't write the
If you didn't write out the square, did you write it out, throw it out twice, that's fine. Now here's the question.
Oh, they're equal.
In this problem here, how many times does this graph cross the x-axis?
Once.
Once. Where?
Right, the 2 marker.
Negative.
I should guess.
At the square.
-2.
3 over 2.
And negative
3 over 2.
3 over 2, yeah.
Oh.
3 over 2.
What were you going to say?
Oh, because I H paid.
Wait, oh yeah, you got to write a square.
So is it 1/2? Is that 1?
1/2 to be 1 over 2.
1.
3 next. 3 over 2. Yeah. Remember, the only thing that changes now, if you throw that equal to 0, the whole problem was equal to 0 all the way down. The only thing that's different is the very last step. You set it equal to 0 and solve it. In this case here, since it was squared, it just means it's the same thing twice. So it's 2x minus 3 is 0, so it's 3 over 2. That's your 0. This parabola only touches the axis at one spot. Okay? It only has one solution.
Wait, I don't understand how the
I
two over
understand.
through.
Okay. I'm so
Are you
lost.
telling us right? I get it.
But it just so happens that this one is, it's supposed to be upside down. So
Yeah.
this is negative,
Ah,
but
okay.
I realized it was negative, but you get the idea. What's up?
Do you have a parabola that's like tilted 90 degrees?
Yes. Well, we do that later.
Sideways parabola?
Think about what you're asking here.
And
The
the y-axis
parabolas
on the y-axis.
what we're having right now are y equals x squared.
Yeah.
That's x equals y squared.
That's pretty cool.
So if you solve that for y, it's the square root of x.
So what's the pun for that? Side, right like a
And it works
light.
out that way.
Right like a light and left like a.
Same process where A values positives opening right, A values negatives going left. We get to that stuff later on. We have a whole bunch of stuff on that, okay?
Can you scroll it up so I can see what I messed up?
All right. The last little bit of this section, that's really all there is to this. Remember, there are special patterns that are out there as far as how you solve some of these things. I'm not really going to get involved with having you guys memorize out a lot of your special product rules, but if you remember them, be better. And this example here was a special product. Is 4 a perfect square?
No. Yes.
Is 9 a perfect square? See how the signs go negative plus?
Oh, that's why you did that.
That means it's the same term twice. What's the square root of 4? What's the square root of 9? So that's how that works. Okay? It works that way especially if you notice here we have 4 and 9. Square root of 4 is 2. Square root of 9 is 3. 2 times 3 is how much?
6.
Double it. What do you get?
12.
So that's how that works. Watch. Be careful though with your signs though. That pattern only works if they're both positive, or if they're negative, or they're both negative.
What do you mean it's 4 and 9?
Then it won't be bad. If it was 4 and 9, then you'd have 16 and 81 for your answers, and 16 and 81 would be the middle term then. Something, I don't know. Okay. Homework-wise, what I want you guys to do is also on that same page. It starts on 260.
Gotta do it again.
It's 5.2,
Do it again.
page 260, number 36 through 88.
Through 88.
Every other even.
Say.
About to say.
Now, I do want you guys to take a quick look at number 99. Number 99 is a word problem that patterns itself off of an example in the book. The example in the book is on page 259, I believe. Okay? It's a 1x4. Okay? It's a very simple one to work with. Number 101, you have to work with your graphing calculator. I'm going to see how you guys set that up. I'm going to show you guys some tricks tomorrow with graphing calculators. Make sure you bring your calculator tomorrow. You really need it because we're solving equations. Notice, we have a quiz on Thursday, 5.1 through 5.4. What we're going to do with 5.3 and 5.4, the first half of section 5.4 is pretty much the same thing as 5.3, except for the fact that you have negative square roots. Which means tomorrow we get to introduce you guys to the imaginary numbers. Okay? The way we solve equations with both 5.3 and 5.4 are identical, except for if it's an imaginary. Lastly, on Wednesday, when we do that 5.4, I put imaginary simplifying. That takes a little bit of work. I'm cutting that into just one day of just, it's basically, remember how you had to simplify radicals? Simplifying with imaginary is a little bit trickier, especially when you have imaginary in your denominator. You want to do some stuff. Okay? We'll quiz out in a bit on Thursday. I don't know what we're doing on Friday. We'll probably go over 5.5. Yes,
Do you
sir.
have a half day Friday? 2x minus 3 and 5x minus 3.